6, we're going to look at other types of equations and just see how this goes. Notice, in the past, what we've done when we have something like this first equation, when we have something like x squared equals 4. You say, well, how do I get rid of the squared? Well, we said that you would take the square root of both sides, and don't forget your plus or minus symbol, which gives you 2 answers for x because the square root and the squared cancel each other out, leaving you with just the x. And we have a plus or minus. The square root of 4 is 2. So that gave you 2 answers. It gave you a positive 2 and a negative 2 for your x. So what we did is to get rid of a squared, we took the square root of both sides. Now we're going to be doing the reverse. To get rid of a square root, we're going to square both sides. But what we want to get used to is when we're doing a power to both sides of an equation, that we go ahead and put both sides of the equation, parentheses around them, and do your exponent. So what will happen is, just like before, the square root and the squared cancel out, leaving you with just the x underneath. However, we're only going to get one answer, not 2. So we've got 2 squared on the other side, which is just a 4. However, we do have to make sure that our answers are what are called valid solutions. Whenever you square both sides of an equation, you might get a false answer, which means you need to check your answers to make sure they're not false solutions. That's what this little warning says. Meaning you don't want to get anything that's going to make a square root equal something negative. You don't want to end up with a negative inside of a square root because that would mean imaginary numbers. Notice the only time you're going to really have to check your answers is when you have an even exponent that you're doing to both sides of the equation. So, in order to square both sides of the equation, be careful though, you have to make sure that the square root is by itself. Just like we couldn't get rid of squaring by using the square root unless the squared term was by itself. So let's take a look at a couple of examples. So let's see. On this first example in problem A, we've got a square root of 4x plus 13 equals 2x minus 1. Now, we've got a square root. We can get rid of the square root by squaring both sides as long as the square root is by itself. The square root on the left-hand side doesn't have anything next to it, so it is by itself. So we'll just get rid of it by squaring the left-hand side. But if you square the left-hand side, you have to take the entire right-hand side and square it as well. So what happens, again, is the square root and the squared cancel out, leaving you with whatever was underneath, which in this case is a 4x plus 13. On the right-hand side, be careful. What we have is a 2x minus 1 that's squared. Now, what does it mean to square something like this? It means that there's 2 identical twinning copies. So there's a 2x minus 1 and another 2x minus 1. So to actually figure out what's going on there, what we have to do is some algebra. We have to FOIL those out by multiplying out your 2x first and then multiplying out your negative 1. So multiplying out your 2x first gets you a 2x times a 2x, which will get you 4x squared. Then the 2x times the negative 1 gets you a negative 2x. Then the negative 1 times the 2x gets you another negative 2x, and a negative 1 times the negative 1 gets you a positive 1. What we're just doing is FOILing here. On the other side, we've left that alone for now. That was a 4x plus 13. Now we've got something that's quadratic, so this will need to eventually equal 0, but before we get there, let's combine like terms. We've got a negative 2x and a negative 2x, which is going to be a negative 4x. When we combine those like terms. And don't forget we've got the plus 1 at the end, And we've still got our 4x plus 13. Now the question becomes, how do we make this equal to 0? Well, we've got almost everything on the right-hand side, so let's get the rest of everything on the right-hand side. So we'll move the 4x to the right by subtracting a 4x from both sides. That will move it. Then we also have a 13 over here on the left-hand side. We'll move that to the right by subtracting a 13 from both sides. So that will move it over. So now that we moved everything over from the left, we have just a 0. And on the right-hand side, we've got, let's see, a 4x squared. Be careful. What else do we have here? We've got a negative 4x and a negative 4x, which is going to give us a negative 8x. What else do we have over here? We have a positive 1 and a negative 13, which will give us a negative 12. And the question would be, does this guy factor? We would want two factors of negative 48 that add up to a negative 8. And what might be a little bit easier, so we can at least deal with smaller numbers, is to go ahead and factor out a greatest common factor. Notice we've got a 4, an 8, and a 12 that are all divisible by 4. So we can make our numbers smaller by factoring out a common factor of 4 from everything, which will leave us with an x squared minus 2x minus 3. That's a whole lot better to deal with, and much smaller numbers. So the only thing we need to be careful about, though, is that we don't actually lose that 4 that was out in front. So we're going to pull down our 4 first, and then we're going to hope that what was left over, the x squared minus 2x minus 3 factors, and it will factor if we can find two factors of negative 3 that add up to negative 2. And there are two factors that will do that. That's an x minus 3 and an x plus 1. But we still need to take all of our pieces and set them equal to 0. Well, the first piece is technically a 4, and so setting 4 equal to 0 doesn't actually do anything because there's no x's there. So that's just not going to even make sense. Got to go to our next piece, which is our x minus 3, and set that equal to 0. Well, adding 3 to both sides of the equation, what that gets us is an x equals 3. So let's see, continuing along, let's set the last thing equal to 0, which is your x plus 1. Setting that equal to 0 means that we would subtract 1 from both sides of the equation, which would get us the fact that x equals negative 1. Now, what I'll see a lot of times on homework and tests and final exams is people say, yes, these are my two final answers, 3 and negative 1. And they'll just either plug those in or choose those from their multiple choice options on the final exam and forget that you squared both sides of the equation, meaning that these might be false solutions. So you need to check them by plugging them into the original equation. So what was the original problem we had? Is we had the square root of 4x plus 13 equals 2x minus 1. So what we need to do is take both of our answers and plug them in and make sure that they work. So let's start out with 3. So plugging in a 3 for all your x's just to make sure it works. So we would end up with the square root of 4 times 3 plus 13 underneath the square root, and 2 times 3 minus 1 on the other side. So what happens is we notice on the left-hand side we get the square root of 4 times 3, which is 12, plus your 13. So, and on the other side we get our 2 times 3, which is 6, minus 1. So we get the square root of 12 plus 13, which is 25, equals the 6 minus 1, which is 5. So does the square root of 25 equal 5? Yes. So what that means is our answer of x equals 3 is not a false solution. It does indeed work. However, you're still not done. You still need to check x equals negative 1 by plugging it in wherever there's an x. So let's try that one as well. So we'd start off by taking the square root of 4 times a negative 1 plus your 13 equals your 2 times negative 1 again minus 1. And let's see what happens on this one. On this one, you get a square root of negative 4 plus 13 on the left, which is going to give us a square root of 9. And on the other side, we get a 2 times negative 1, which is negative 2 minus 1, which will give us negative 2 minus 1 is negative 3. So does the square root of 9 equal negative 3? No, it does not, which means actually the x equals negative 1 doesn't work, which means I had 2 answers, but only one of the 2 actually worked. Only the number 3 worked. So our final answer is just the x equals 3, because the